Hi guys, sorry I can't be there today. I was grading the tests and I didn't want to not come to school today and not leave you guys with some additional instruction. So these 5 questions, is that right? 1, 2, 3, 4, 5, were the ones that we really struggled on. And I want to make sure that I give you a little bit of extra time to rethink some of these problems. And so follow along with the worksheet. I'm going to go in detail through all of these, and hopefully that gives you a second chance as to look through them. These are very similar to the questions that were on the test, except these are not the actual test questions, so you can feel free to hang on to this worksheet, or at least submit it at the end of the day. So the 5 questions that I've got going on here, I'm going to go over, and then if you flip over the back, there's some extra practice, and you guys are going to submit that worksheet to me. And if you do that, I can give you guys some additional points on the test to make sure that you really understand it. So I'm going to be looking for correctness on this worksheet, so make sure that you are paying attention and you're talking through with the people at your table after you finish watching this video, making sure that you go through the problems and not just copying things down without understanding. Tomorrow when I come back, I'm going to give you a chance to actually do the problems on the test one more time so that you can get some retake points that way as well. All right, so there's going to be some opportunity for you to show me some growth. All right, let's start with this one. The problem that I have with this answer, a lot of you left this answer as is on the test, but there's a few problems with it. Number 1, there's a 0 exponent. So there's this issue I have to fix here, and the other issue I have to address is negative exponents. So there are 2 issues that I have to fix. If you haven't fixed either of those, then we've got a problem. So you can't just leave the statement as is. All right, so if you remember, when you raise a base to a 0 exponent, the result of that is 1. So this exponent of 0 matches with this base a. The 8 is not a part of that. So this whole thing turns into the number 1. And so what you really have here is a negative 8 attached to a 1 by multiplication. There's a secret times symbol in there. So what this really says is negative 8 times 1. But negative 8 times 1 is just negative 8. So if I multiply that through, I'm going to get this statement. Before I circle my final answer, I have to double check. Have I fixed all my issues? So I don't have any more 0 exponents. I don't have any letters that I can combine, but I have a negative exponent. So if you remember, to change the sign of the exponent, we change location. And I don't have a location in there until I put a fraction in there, right? So I'm going to put a fraction bar in there. And that negative 9, I want to change its sign. But that negative 9 is attached to the b. So if I want to change that negative 9 and make it positive, I can do that, but it has to come along with the b. Negative 9 is an exponent, just can't move on its own. And it's only going to take the b. It's not going to take the negative 8 because the negative 8 is not attached to that exponent. So I'm going to move that downstairs. And when I move that b downstairs, the exponent becomes negative. So when you change locations here, the sign changes as well. So now this happens. A lot of kids were trying to move that negative 8 downstairs here, but the thing is, this is not a negative exponent. The rules of moving and changing location depending on the sign is only dependent on if it's an exponent, not if it's a number itself, all right? So the short story here is, when I see a problem that looks like this, a to the 0 turns out to be 1, so I don't have to really worry about that. I've got this statement here. I see a negative exponent. It's negative upstairs, so I move it downstairs, and when I move it downstairs, it disappears from upstairs, and so that's my final answer here. Negative 8 C4 over B9. There are no negative exponents, no zeros. There are no double letters to combine, meaning there's no same letter in a different location. And this negative 8 is not an exponent. So that's my final answer for this. So when I move on to the next one, it looks a little bit more complicated. But again, remember, anything that's raised to the 0 is 1. So, excuse me, 0 is my exponent. The base that it's attached to is that whole thing. So that whole thing turns out to be a 1. Sorry, guys. So this thing here, that whole thing turns out to be a 1. And then I'm just going to bring that statement down. Again, remember, anytime you have a 1 there, it keeps this thing the same. So essentially we do the same exact thing here as we did here. That a to the 0 turned out to be 1, which was inconsequential because there was other stuff with it. So same thing here. This whole thing can cross out because anything raised to a 0 is 1, and I've got other stuff there, so that 1 doesn't bother that stuff. So what I really just have to do is figure this statement out, right? So that 3 is going to go along to everything inside the parenthesis. So the 2 is going to get the 3, and the x is going to get the 3 as well, but the x is already attached to a 4, and that 4 is a power to a power, so when the powers are next to each other, we multiply those numbers together. So we've got that. And then 2, when it got the 3, it became 2 to the 3rd power, and remember, 2 to the 3rd means 2 times 2 times 2, which is 8x to the 12th. So short story here, if you're going to do this with anything, I'm just going to make up some numbers. 5x to the 4th to the 2nd power. If you imagine this gone, 5 squared is 25. So that's where the 25 comes from. This x to the 4th to the 2nd becomes an x. Obviously, the base is still the same. And when bases are next to each other, exponents are next to each other, we multiply them. So 4 and 3 gives me my 12. If you cross this out and pretend like that says 2 cubed is 2 times 2 times 2, which is 8. So there's lots of little shortcuts that you can take. All right, moving on to this problem. There's a lot going on there. The first thing I notice is that there are x's in multiple locations, and y's in multiple locations. So I can't go ahead and just like fix the problem by not addressing the double letters, right? But imagine what it would look like if it was just the stuff that wasn't complicated. If we take all the complicated crud out, you've basically just got a problem that's asking you to multiply 9 times negative 2. So if it says multiply times 9 times negative 2, then that's what we do. We multiply that. The numbers in front follow normal convention. So like what I mean by that is whatever the sign is here, that's what you do with the numbers out in front. Because all the other stuff has rules. Numbers don't have rules. They just follow exactly what they're told to do. So that's where the negative 18 comes from. Back to the double letters. X to the negative 8 is combinable with this. And y2 is combinable with y6. So if you remember, if you've got y2 times y6, y2 literally means y times y. This dot here in the middle, I'm just going to exaggerate it. Y to the 6th is y times y times y times y times y times y. And this is the long way of writing y to the 8th. So the easiest idea is to say, oh, I know what happened here. We're just going to take the exponents and add them. When the bases are being multiplied, we add the exponents. When the exponents are being raised, when they're next to each other, that's when we multiply them. So a situation like this, we add. In a situation like this, we multiply. Okay? So 9 and negative 2 makes negative 18. That's the multiplication. I've got a y2 and a y6, so together that's y8. And then we've got x, so I'm going to do the exact same thing. If what I did with the x's, the y or the 2 and the 6, is what should I do with these numbers as well? So if you remember, this x has a 1 with it. A lot of you guys were leaving that negative 8 or whatever this number was alone, but remember, x on its own has an exponent of 1. So negative 1 or negative 8 plus 1 is negative 7. So before I circle my final answer, I'm going to make sure that I don't have any issues. Are there any repeat letters? No, there's just one single y and one single x. It's not like here where there are x's and y's all over the place. Are there any things to fix? Yeah, that negative exponent. To change the sign, we change location. There is no location, so what that means is we're going to draw a fraction bar, identify the problem. That's the problem. It's directly attached to that x, so fix it by moving it downstairs. When you change the location, you change the sign of the x. Not the x itself, but the exponent. So move that downstairs. And again, I don't have a problem with negative 18. Negative 18 isn't an exponent. It's a coefficient. So you leave it alone. So this whole craziness turns into this. 9 times 2 is negative 18. Negative 8 with a 1 is negative 7. That was here. It moved downstairs. y2 and y6 makes y8. No repeat letters. No negative exponents. Negative 18 is fine on its own. That's when I'm ready to circle my final answer. Now if we move on to this one. All right, there's a lot going on here. If you notice, the y's are not next to each other. They're above. It's a little different now. If the y's were next to each other, we added these numbers. So if the y's are being divided, now we subtract them. So I'm going to leave the 12 and the 16 all on its own, and then I'm going to subtract the things that are alike. And when I say alike, I mean the x, like the same letters. So x14 and x8 are combinable. Y's are combinable, but x and y's are not. So I'm going to just subtract. 18 minus 11 is 7. I would rather do 18 minus 11. Since 18's on top, the y ends up on top with an exponent of 7 because 18 minus 11 is 7. I'm going to do the same thing here, but instead of doing 8 minus 14, I would rather do 14 minus 8. And if I start with 14, which is downstairs, I'm going to end up where 14 lives, which is downstairs. Again, I'm subtracting these. So 14 minus 8 is 6. All right, so let's do that one more time, just real fast. I've got this exponent, double letters, 12, 16 out in front. Would I rather do 8 minus 14 or 14 minus 8? 14 minus 8. Where's the 14? Downstairs. So where's your x going to end up? Downstairs. To what power? Whatever 14 minus 8 is, 6. Would I rather do 18 minus 11 or 11 minus 18? 18 minus 11. 18's on top. The y is going to end up on top to whatever the subtracted power is. 18 minus 11 is 7. So you're almost done. No negative exponents, no double letters. The only thing you have to think about is, oh wait, these numbers out in front are reducible. So you can either replace them in your calculator and figure out what that reduces to. So if we do that, 12 divided by 16 reduces to 0.75, which is 3/4. I'm going to just tap the fraction decimal conversion, 3/4. So that 12/16 turns into 3/4, and here's my final answer. You could have also done that by thinking what you can divide 12 and 16 by. You can divide 12 and 16 by 4. So 12 divided by 4 is 3. 16 divided by 4 is 4. And again, that's your solution. No double letters, no negative or zero exponents. These numbers are reduced from that. Again, you could do that on the calculator, or you could do that in your brain by dividing by 4 or whatever number it is here. But combinable. If things are combinable, combine it. This is combinable by multiplying 3 and 4. This is combinable by adding the 2 and the 6. These are combinable by subtraction. 6 minus 2, 6 is on top, so y 4. Then you can leave 1 as a placeholder downstairs if you want, or vice versa. If you've got y2 over y6, I would rather do 6 minus 2 as well. So in this case, the 4 ends up downstairs and the 1 ends up on top. All right, so everything is combinable. You just have to know the rules. All right, one more problem here. A lot of you guys tried to make this 3 go into here first. You can totally do that, but sometimes it's easier to figure this out first. So like, let's pretend that that 3 isn't there. That's really annoying, right? Like it's there and it's distracting you. So just think about what it looks like if it wasn't there. Scratch it out temporarily. So the first thing I'm going to fix is I don't like that g negative 2. So to change the sign, you change location. So I'm just going to move that g negative 2 downstairs. But when I move it downstairs, that g becomes positive. Then I've got 2 g's next to each other. When the g's are next to each other, they're being multiplied, which means we add the exponent. So now we've got g7. And now we've got 12 divided by 4. And again, you can divide that out. Maybe you know, maybe you don't, but you can always use a calculator. 12 divided by 4 is the same thing as 3, which is 3 over 1. So I'm going to do one of these. 3 over 1, and that g7 again is downstairs. Remember, the bigger number was on top, so the bigger number stays on top. 12 divided by 4 is 3, but don't forget the g7 doesn't go upstairs. The g7 stays downstairs. So all that was finding what this inside simplified to. No one ever actually asked you to do that because we asked you to cube that or to put that to the 3rd power. So we figured out the inside of this, which turned out to be this, but now we're ready to do that 3rd there. So one way that you can do this is figure out what the inside is simplified, which means just combine your double letters, fix your negative exponents, think about what that is on its own, and now you can distribute that 3 to the inside. The 3 gets the 3. The 1 gets the 3, and so does the g. But remember, the g is attached to the 7. And when you have a power to a power, we're going to multiply those together. So right now, 7 times 3 is 21. So I'm going to figure out what that is. 1 to the 3rd power is just 1 times 1 times 1, which is 1. I'm not going to write the 1 there because there's already a g21 there as a placeholder. 3 cubed means 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. So that is my final answer here. So my suggestion to you guys is think about simplifying the inside of this first and then raising it to the third power. So figure out what this inside is, get it simple, and then worry about that exponent here. And that might make it easier. Okay, hope this video wasn't too long. Hope this makes sense to you guys. Flip over the worksheet, work on it together, talk to each other, get the extra practice, and then I'll give you some points for this, and I'll give you it'll give you a chance to prep for the retake tomorrow, and not the whole thing. I just want to give you guys a second shot at some of these kinds of problems. All right, hope that helps.